So next we'll look at multiplying, dividing rational expressions. So in other words, like multiplying, dividing fractions. Again, you remember that one of the keys to multiplying fractions was actually reducing before you multiply straight across. So before we multiply straight across, recall that we want to look for common divisors. So again, if you instead of trying to do all this prime factorization stuff, these numbers aren't that bad. So notice how we should be able to see that 8 does go into 16, so I can do what we call cancel or divide out. So that would turn into a 1, and 8 does go into 16 twice, so I divide the numerator and denominator both by an 8, because remember, that's just turning into a 1. Then if you look at the other diagonal, notice how the 5 and the 25 both can be, you can divide a 5 out of each one of those. So 5 turns into a 1, and 25 divided by 5 would be a 5. So if we put it all together, you would see that the answer just becomes then 2/5. Now, when it comes to dividing, remember, we don't really divide. We use what's called, KCF, Kentucky Chicken Fry. Kentucky Chicken Fry kind of means keep, change, flip. So that's an acronym to kind of help us with the strategy of dividing fractions. Because remember, dividing is the same thing as multiplying by the reciprocal. So here I have like 7/16 and divided by 2/1. Notice how I can change it though to 7/16 times 1/2. Now notice that there's nothing really to cancel from the numerator and denominators. So all you really can do is just multiply straight across, and that becomes then 7/32. So if I look at this next example, before we start multiplying, notice how there's this xy to the third in parentheses. The first thing I need to do is bring that 3 through the parentheses using one of the laws of exponents there. So this problem gets rewritten and then as 15x y squared over x y cubed times then this is going to become x cubed y cubed over this 5x. Now, to make this a little bit easier on this one, it's probably easier to go ahead and just multiply straight across first and then start canceling. So I would go ahead and just multiply, the 15, there's nothing to multiply on the top by, but also you have this x, you have this x times x to the third, that's going to be x to the fourth, and this y squared times y to the third. So remember how we add exponents there, that's going to be x to the fourth, y to the fifth on the top. And then on the bottom, I would put the 5 out in front, and then the x times the x is going to give me this x squared. So this is going to give me this 5x squared y cubed on the bottom. And then from there, we can start kind of reducing and canceling and things like that. So notice how the 15 and the 5 both have a common factor of 5 in them. So I divide that 5 out. That leaves me a 5 on the top, and that turns into a 1. So from there, really, we're just trying to do the rest of this math kind of mentally. So I kind of make my fraction bar. So this 5 stays put on the top. Notice how there's 4 x's on the top here, and there's 2 x's on the bottom. So if we subtract, that leaves us 2 x's left on the top. That's going to be an x squared there. And then on the y to the fifth over y to the third, if we subtract there, we have 2 left, and that's going to be also on the top. And so therefore we have a 1 on the bottom. But remember, when the 1's on the bottom, we're allowed to drop it because division by 1 doesn't really change anything. So this becomes then 5x squared y squared as our simplified version of that. So we're going to take this to the next level, and that's going to be working with polynomials. So one of the things we'll pick up on with polynomials is when you're multiplying and dividing, the strategy is still all about this factored form stuff. So some things that we want to look for is if there's any division, go ahead and change that into multiplication by, Kentucky Chicken Fry. In other words, flipping the divisor, the second piece. The next thing is we want to do is, factor completely every numerator and denominator as possible. And then we want to reduce factors by dividing out any common factors. And then what we want to do is multiply the remaining factors together. And the result can be written in what's called factored or expanded form. So if I look at A, I have this x squared minus this 4x minus this 12 over 2x minus 12 times then. And since it's multiplication, we just write the same thing, x minus 4 over x squared plus 4x. Now, it might not have been a bad idea to go ahead and begin factoring instead of rewriting the whole problem over. Just go ahead and do factored form. So if I look at this first one, x squared minus 4x minus 12, notice that is not a perfect square trinomial. So it's a general trinomial. So general trinomials, you can use 4 square as a method of thinking. So the quadratic term is in the top left, the constants in the bottom right. And so what I pick up on is since the coefficient of x squared is 1, all I have to do is focus on the factors of a negative 12 that give me the linear terms coefficient, which is that negative 4. So the factors of a negative 12 add up to give me this negative 4. So again, we have a 1 and a 12, a 2 and a 6, and a 3 and a 4, 4 and a 3. So it looks like the best potential really is this 2 and 6. So what we pick up on is to get a negative 12, one of them's got to be negative. But to get a negative 4, that means the 6 is going to be negative. So what happens then is the 2 and the negative 6 become our coefficients of our linear terms. So the 2x comes here, and the negative 6x goes there. So from there, what's kind of nice is mentally, you can kind of see when you pull out these edges here, the GCF would be an x. We also can just pick up on x times x is the only way to get x squared here. So this becomes our edges here. And then what we're trying to figure out is, what times x gives me 2x? That's going to have to be a 2. And then we drop down to the bottom, what times x gives me negative 6x? I need a negative 6. And does negative 6 times 2 give me this negative 12? And it does. So really what it all boils down to is when the quadratic term is just x squared, all you're really looking for are the factors of a negative 12 that have to give me negative 4. So really all we need is, we don't necessarily need this organizer as much as we just need big T or that thinking. So this turns this into then x minus 6 times x plus 2 is the factorization there. On the bottom, 2x plus 12, the only thing we can pick up on there is it's not a difference of squares, but it does have a GCF of 2. So I factor that 2 out, that becomes an x minus a 6. The x minus 4 is prime, it doesn't factor. On the bottom, x plus 4 squared, that's going to be actually that looks like a perfect square trinomial because, if I run that through my system, x squared is a perfect square. 4 is a perfect square because 2 squared is that. And if you multiply 2 times 2x and double that, 2 times 2x and double it, that does give you 4x. That is the middle term. So that means that is a perfect square. That's going to factor into x plus 2 squared. So once everything's factored, we're looking to cancel out like factors on the top and the bottom. So what we're saying here is this x minus 6 does divide here. This x plus 2 does divide with one of those x plus 2. So I'm actually just going to mark out the exponent instead because we're still left with an x plus 2 there. And that's all I'm seeing left is the in the numerator, the x minus 4 is left. In the denominator, we have 2 times x plus 2. So that's the factored form, where if you expand it out, the numerator can't be expanded, but the denominator can be 2x plus 4. So that would be the expanded form. So when I look at B, notice how this is actually division. So remember that second fraction is going to actually flip. So the 4y squared is going to stay put minus the 9. The 2y squared is going to be staying put. But when I change this to multiplication, the division problem flips over. So 4y squared plus 12y becomes the numerator. And the y squared minus the 2y minus the 15 becomes the denominator. So once we have it in that form, we want to factor as we can. So let's say 4y squared minus 9 is actually a difference in squares. So it's going to be actually 2y minus 3 times 2y plus 3. The 2y squared is really not factorable. The 4y squared plus 12y does have a GCF of 4 and a y. So it's going to leave me a y plus 3. And on the bottom, y squared minus 2y minus 15, that's a general trinomial. So basically what we're looking at is, what are the factors of negative 15? Since the coefficient of y squared is just a 1, we just got to focus on the negative 15. That have to give me this negative 2. So we have a 1 and a 15, and a 3 and a 5 is my mental thinking. So 3 and a 5. The 3 and 5 looks pretty good, actually. So that looks like a winner. But to get a negative 2, that means that 5's got to be negative. So that means that the y squared minus the 2y minus the 15 is going to factor into y plus 3 times y minus 5. So from there, we start to try to cancel out our factors. So the 2y minus 3 is, I don't see that happening anywhere. What I do see, though, is this 4 is going to cancel with this 2 here. This is going to leave me a 2. This y is going to cancel and leave me a 1y down here. And this y plus 3 is going to cancel out there. So that's all I'm seeing that can cancel. So if I put this all back together in factored form, I'm going to go ahead and put the 2 out in front. And then I'm going to have this 2y minus 3 times this 2y plus 3. And on the bottom, we would have just the y is left over times then a y minus 5. So we could leave it like that, or we could put it back in an expanded form. If I put it in expanded form, notice that 2y minus 3 times 2y plus 3 is that difference in squares. That's going to go back to the original form. That's going to be 2 times then 4y squared minus 9. On the bottom, if I multiply the y through, that's going to be y squared minus 5y. And then if I want to multiply the 2 through, that's going to give me 8y squared minus 18 over then y squared minus 5y. That would be the expanded form. So either one of those are what we're looking for, factored form or expanded form. Just have to pay attention in my lab which one they want. So the next thing we have what's going on is what's called complex rational expressions. A complex rational expression is when you have like a rational expression divided by another rational expression. It creates a complex number. So we're looking at things that look like this. So these are called complex fractions or rational expressions. So the easiest way to deal with these is rewrite the complex rational expression using the division symbol, the dash with the 2 dots, and then we multiply by the reciprocal. So if I look at this example here, notice how the 4xy is being divided by, it's being divided by the 2x over the 5. So what I can do is change this to 4xy times then and flip it, and that becomes 5 over 2x. So then if I want to make this look like a fraction, I can put that 4xy over 1, and I can look for canceling out like factors. Notice how the 4 and the 2 are a common factor of 2 there. That's going to cancel and become a 2. Again, I'm using division there when I say cancel. Notice how these x's also divide out or cancel out. So if I put this all back together, what I'm seeing then is a 2 and a 5 is 10. There's a 10y, and then on the bottom, there's just a 1. So this just becomes then 10y. So if I look at B, notice how this is my division symbol here. So what I want to do is write this as x squared minus y squared over 2x. And instead of using division, we're going to use multiplication. But doing that, this x minus y over 3x squared has to flip over. That's going to now be 3x squared over x minus y. So now we can apply factorization principles. Notice that x squared minus y squared is a difference of squares. That's going to be x minus y times x plus y. The 2x stays as is. The 3x squared stays as is. And the x minus y stays as is. There's nothing to do there. So then we look for factors that we can cancel. Notice how this x minus y does cancel with this x minus y. Notice how the 3 and the 2 are numbers, but they don't have any common factors except for 1, and that's not going to do anything. But notice how the x's, I can cancel out an x. So this x is gone, and that just leaves me with 1x there, if you will. So if we put this all together, I'm going to put the 3x out in front, and then the x plus y. And on the bottom, we would have 2. So that would be the answer in factored form. Or if we multiply the 3x through, we could say 3x squared plus 3xy. So 3xy. That looks horrible. Try that again. Trying to find my mouse. I didn't like that pin next to it there. Okay. Get this thing back on some solid ground. So this becomes then this 3xy over then 2. Okay, let's see what else we have here. So another thing we have what's going on is rationalizing the denominator. Remember with radicals, there's what's called irrational and rational. Irrational means there's a radical present. Rational means there's no radical present. It's typically what we call numbers that can be expressed as fractions or decimals. So remember, like we did with imaginary numbers, we can use what's called a conjugate to get rid of imaginary numbers. We also can use the conjugate here. So notice how the denominator is this 2 minus 5 square root of 5. We do not want this square root of 5 on the bottom. I'm sorry, the square root of 2 on the bottom. So to rationalize this, what we do is we multiply by what's called the conjugate. So remember, the conjugate of 2 minus 5 squared 2 is going to be 2 plus 5 squared 2. Remember, the signs just got to be different. That's that conjugate stuff. But remember, to keep it to equivalent, you have to multiply the numerator by the same thing. So we have we got to multiply the top by 2 plus 5 squared 2. So to multiply the top together, I'm going to use 4 square as an organizer. So I have 1 plus 2 square root of 3 here. We have 2 plus 5 square root of 2 here. So you can use FOIL or 4 square. So if I multiply this out, 2 times 2 is going to be 2. 1 times 5 radical 2 is going to be 5 radical 2. 2 square root of 3 times 2 is going to be 4 square root of 3. And then 2 square root of 3 times 5 square root of 2 is going to be 10 square root of 6. So the numerator, there's no like terms. So that's just going to be then 2 plus 5 square root of 2 plus 4 square root of 3 plus 10 square root of 6. Those are not like terms. And then on the bottom, remember with conjugates, all you got to do is square the first term. Well, 2 times 2 is going to be this 4. And then if you square the last terms, that's going to be a a 5 radical 2 times a 5 radical 2. So notice how that's going to be 5 times 5 is going to be 25. But remember, with square roots, if you have two of the same factor, that comes out as a single factor. So that's actually going to be the same thing as 25 times 2, which is going to be 50. So this is going to be a minus 50 on the bottom. So in turn, this becomes then 2 plus 5 squared root of 2 plus 4 squared root of 3 plus 10 squared root of 6 over negative 46. And again, if you want, you can put the negative out in front or on the top. So we could leave it like that if we want. Or if we want, we could pull the negative out in front and say, 2 plus 5 squared root of 2 plus 4 squared root of 3 plus 10 squared root of 6 over negative positive 46 now. You also could bring the negative through the top and change all the signs in the top as well if you wanted to. But I'm going to leave it for that for the time being. So that's how we kind of work with multiplying and dividing rational expressions, and also a little bit on rationalizing when we have radicals involved in the denominator.